All right, Math 1, this is your homework help video, which is the study guide. Today is Wednesday. We're doing 17 and we're going to complete the rest of them. All right, so a system of equations. This is a system because it's more than one equation. They want to know which x value is the solution to the system. So you're looking for where they cross each other. And wherever they cross, remember, that's a point. The point that they cross, you're looking for this value. So you have to figure out where do they cross. So in order to figure out where they cross, I'm going to clear my calculator. 2 plus 7, 1, 2. I'm going to graph them both. So I'm going to graph the first one, which is a linear function. That's 9x plus 5. I'm going to graph the second one, which is 2x squared. This is a quadratic function because it has an x squared term. So now I'm going to graph them both. All right, so this is the point in which they cross each other right here. So to find that point, you press second trace and you go to intersect. All right, you're going to press enter on the first equation. Look at the top, that's the first. And press enter on the second equation. You see, look at the top, that's the second equation. And now you're going to press enter and it says guess. That means it's going to calculate. So when you press enter there, the intersection is this right here. So the x is a negative 0.5 or negative 1/2 and positive 1/2. That's where it crosses. So the x value is a negative 1/2. So negative 1/2 is B. Okay? So B is going to be your answer here. Hold on, let me get my paper. Oh, all right. So 17, we're going to put number 17, and B is our answer because it was a negative 0.5, the x value, and positive 0.5 was the y value. This was the value that we were looking for. Number 18, all right. If this is the expression, which is the equivalent expression factor. So we have to factor that. We're factoring 2x squared minus 10x minus 48. So that's what we are factoring. Move this to the side. All right. So in order to factor this, slide this out the way. Okay, you look for a GCF first. So your GCF here is going to be 2. I'm going to take out a 2. So when I take out a 2, I'm left with the x squared term minus 5, because 2 times this will give me that. 2 times negative 5x will give me negative 10x. And then 2 times a negative 24 is going to give me negative 48. All right, so now I'm going to factor this. So 2, we'll leave 2 out to the outside, and let's factor this. No other term, nothing else we can take out there, GCF. So we are going to have 2 parentheses, 2 binomials, because this is a trinomial with 1 up front. So we got x here and an x here. We're going to do our t-chart where we multiply the first and last. That gives us negative 24. The middle number is a negative 5, so your sum needs to be a negative 5. All right, so you have to think, what 2 numbers can be multiplied to give you together to give you a negative 24? Okay, so we have 3 and 8. So we got, let's see, negative 8 and a positive 3. So negative 8 plus 3 gives you a negative 5. So here we got negative 8, so that's minus 8, x minus 8, and positive 3, x plus 3. Bring down the 2. Okay, so now we're looking for that. Okay, so we're looking for that answer. So we have 2, then we have x plus 3, that's right, x plus 3, and an x minus 8. So it's going to be B. So B is our answer here. Okay. Number 19. Okay, it says which equation of the function with a 0 of 7. So you got to factor it and find the zeros to see which one of these problems have a 0 of positive 7. So A, we're going to factor that one. We have y is equal to x squared plus 7x plus 10. So this is 0, okay? X squared plus 7x plus 10. So you're going to look for a GCF. There's no GCF other than 1. There's a 1 up front here, so you're going to have binomials with x in each, and you're going to make a t-chart. Multiply the first and last, that's going to be a positive 10. Sum of the middle number, a positive 7. So we have 2 and 5. 2 plus 5 is equal to 7. So we have plus 2 and plus 5. So now, in order to solve this, to figure out what the zeros are, you set each of these factors equal to 0. Okay? So when you set it equal to 0 here, you get minus 2, and that gives you x is equal to a negative 2. And here, to get x by itself, you subtract 5. So your x value here is going to be a negative 5. Okay? Neither one of them have a positive 7. So let's move to B. Your B is y is equal to, your letter choice B, sorry. Y is equal to x squared plus 9x plus 14. Do the same thing again. This needs to be 0 because you're looking for your zeros, okay, or your x-intercepts. You're solving the quadratic function. Ms. Reyes, please make sure you write the right number. All right, so we're going to do the same thing again. GCF, there isn't a GCF, okay? So nothing we can take out. This is a trinomial. We're going to have x in each. The first number, your A value here is 1. So that's why we're doing it, factoring it like this. So this gives you a positive 14, okay? And this gives you a positive 9. You're looking for two numbers that can be multiplied to give you 14, but when you add them, you get 9, and that's going to be 2 and 7. Okay, so we got 2 plus 7. So this is going to be positive 2 and positive 7. So when now you set them each equal to 0. So this is x plus 2 is equal to 0. X plus 7 is equal to 0. Subtract 2 on both sides and you get an x of negative 2. Subtract 7 on both sides and you get an x value of negative 7. Okay, still no positive 7 here. Negative 7, but not a positive 7. So now let's do C. I'll do C and D over here. So let's do C. Your C answer is y is equal to x squared minus 9x plus 14. All right, so let's see. All right, so we're going to do the same thing again, no GCF. This has to be equal to 0 because you're finding your zeros or your x-intercepts. So y is always going to be 0 if it crosses the x-axis. So same thing, x here, use your t-chart. So you got 14, and this time it's negative 9. So you got negative 2 times negative 7. So when you add those together, negative 2 plus negative 7, yes, that gives you a negative 9. So this is minus 2, this is minus 7. So now you're going to set each of these equal to 0 to see where the parabola crosses the x-axis. So this is x minus 2 is equal to 0. You add 2 to both sides to get x by itself, and you get x is equal to 2. Set this equal to 0. You're going to add 7 on both sides. So this gives you x is equal to a 7. So C is where your x is equal to, one of your x-intercepts is 7. So C is going to be your answer here. On the test, you need to do all of them just to make sure that you didn't make a mistake, okay? All right, number 20. I'm going to do 20 up here so I have some space, okay? All right. So, number 20 says the function f of x, and then you got, this is the equation here, models the area of the rectangle with the length of the sides in inches. The function, this is the second function, okay, models the area of the second rectangle with the same side lengths. Which function, and they're naming that new function or the other function h of x. It's just that's just what they're doing. It still means y. Of can be used to determine how much larger the second is. So if I want to know how much larger the second is than the first one, I subtract them. The larger minus the one that's smaller. So that's the second one minus the first one. So I'm going to do that. This is the second one. The second one is this 2x squared plus 2x plus 7. And I'm going to subtract it from the area of the first, but I'm going to put it under the like term, okay? Because you can only subtract ones that have the same like term. So I'm going to set it up just like that. All right, and now I'm going to subtract. So when I subtract, this is a 1 here. So we got 2 minus 1, which is 1x squared, or just x squared. Okay. Then we got 2 minus the 3. And if you need to see it side by side, it's 2 minus a negative 3, which is plus a positive. So that's plus 5x. Okay. And then you have, what's this one? Then you have 7 minus 21. And so then that is going to be 14. Okay. So this is going to be, wait a minute, minus 14. Okay. So let's see which one of these is going to be that answer. All right. And that answer choice is D. So D is the answer for number 20. All right. Let's look at number 21. What are the coordinates of the vertex? So we're finding the vertex here. So of this parabola. So remember the equation. We're going to copy that down for, and we're going to label our A, our B, and our C. Your A is the number that's in front of the x squared term, which is 1. Your B is the number that's attached to the x, which is 4. And C has no variable attached to it. So that's negative 6. The formula for the vertex, you got to find the axis of symmetry first. The formula for AOS, or axis of symmetry, is going to be x is equal to a negative b divided by 2a. So this is going to be, I'm going to do axis over here and vertex over here. How about that? All right, so this is going to be a negative, b is 4, divided by 2 times 1. So this gives me an x value. We got negative 4 on the top and 2 on the bottom. So that's going to be a negative 2. Okay, so that's negative 2. So let's substitute negative 2 into the equation to figure out your y value. Okay, so you got y is equal to negative 2 squared. Make sure you put it in parentheses, plus 4 times negative 2 minus 6. So this is calculator active, so you can type this in a calculator. So that's parentheses. Don't forget to use parentheses. Negative 2 parentheses. We got squared plus 4. In parentheses, we got negative 2. Okay. And this is minus the 6. So that gives us a negative 10. So your y here is negative 10. So the vertex is going to be negative 2 comma negative 10. All right. And so 21, that answer for 21 is B. So we put B as our answer. This is 21. Okay. All right. So let's turn over to the back and let's do 22. All right. 22. It says, what is the number of x-intercepts that the graph of this function has? So let's graph it to see. Go to y equals, clear out the equations that are there. And now let's type this in. We got 25x squared plus 4. And let's graph it to see how many times it crosses the x-axis. Look at this. Let's zoom in a little bit. Okay, zoom out. Wow. All right, it doesn't touch the x-axis at all. See it? So, and I could make this to where I could make this, change the window range, and I could go in a little bit more. So instead of doing negative 10, I can go negative 5 to positive 5. That might zoom in just a little bit more. You see it? So now you can see it a little bit better. Okay. All right. So this has 0 lines. It doesn't cross the x-axis at all. So 22 is A, and 0, no x-intercept. Doesn't have any x-intercepts, no roots, and no zeros. Okay. Number 23, or that was 22. All right. Number 23. Jenny used this expression to determine the height of the object after X seconds after it hit into the air. How long does it take for the object to hit the ground? All right, so to hit the ground, you're finding the zeros. So go to y equals again, and we're going to type this in, negative 16x squared, okay, plus 38x plus 5. Graph it. All right. Okay, and so this is what we're looking for, where it hit the ground right here. So go second trace and go to zeros, and this is the side you need to be on. So press the arrow over and look at the bottom. You can see where it is. It's in this quadrant up here, all the way up here somewhere. And keep going over. It's coming closer right here. See it? So you're going to press enter right above the x-axis, and then enter again right below. Okay? Press enter on guess, and this is where it crosses. So it takes, this is what we're looking for, the x value. Okay? This is how many seconds it takes for it to hit the ground, 2.5 seconds. So we got 2.5 seconds C. So number 23 is 2.5 seconds. Okay? All right. Number 24. Joseph and Brent are standing on the roof of a house of houses. Both threw a ball in the air. The height of the ball of X seconds after Joseph threw it is represented. So this is the equation that describes Joseph's throw. Okay. The height of this is Brent down here at the bottom. So let's see what they want us to do. Which of these statements in comparing the paths is correct? So we got a graph for this one. We need a graph for this one. So let's use our calculator to graph that. So clear it and let's graph Joseph's, okay? So Joseph's going to be in the calculator. So it's negative 16x squared plus 24x plus 5. Okay, so that's what we have. So now we're going to graph that, and we probably have to make some adjustments, and we do. We have to make a little bit of adjustments, so I'm going to go up some more. So we got window, and I'm going to go up to maybe 30. Let's see how that goes. All right, good. You see, now I got a better view of that. So, what is it asking us? Okay, it says, we got to read which one's correct. The height from which Joseph threw the ball was 2 feet greater than the height from where Brent threw the ball. Okay, Joseph threw the ball at 5. You see right here? The starting is at 5. So this is Joseph. He threw it at 5. Now Brent threw the ball at 8. So this is Joe and this is Brent. Oops, sorry. Brent is at 8. So it's saying that the height in which Joe, which is 5, was 2 feet greater than Brent. No, that's not true. The ball that Joseph threw was in the air for approximately, this is Joseph, 0.25 seconds more than the time. Okay, so look. This is where he threw it. This is in the middle. This is, oh gosh, how many seconds? Okay, so this is 1.5 seconds. It was in the air 1.5 seconds. So it's in the middle between this is 1.25. So in the middle between 1.25 and um zero point 0.5 is what? Okay, let me see. So let's see, 1.25 plus 1.5 divided by 2, the middle is going to be 1.3. So this right here is 1.375. Okay, so it hit the ground at 1.375. Okay, so when did it hit the ground for? That was for Joseph. Let's do Brent. It hit the ground here, so that's second trace, and we're finding the zeros. We're going to do this side again when it hit the ground. So go over, get close to the x-axis right here, go a little under the x-axis here, and you get 1.6. Yikes, that's 1.6 for Brent. I mean for Joe. Okay, 1.6 and some change. All right, so it says it's approximately point. So when you subtract those from each other, you got 1.6 minus 1.375. 2.22. That's a possible. Let's see. Joseph threw it approximately, so that's an estimated 0.25 more seconds. Joseph more seconds. Yeah. Yikes. That's a possible answer. Let's see if there's a better one. The ball that Joseph threw in the air was approximately more time than Brent. No, no, because it was closer here. The B answer is closer than this one. The ball that Joseph threw 14 feet went 14 feet above the roof of his house compared to 12 feet above the roof of the house. All right, so that's this right here. This is 12, okay? And that's for Brent. And let's do Joseph, this point, second trace. So maximum, let's see, go on the other side, back over here. Okay, so enter here and go on the other side and press enter. So this highest point right here is 14. So 14. So Joseph threw 14 feet above the roof. That's true. In comparison to, yes, that's so D is the better answer. It's a perfect answer. Okay. All right. Let's do 25. So 24, sorry, is D. All right. 25. Compared the maximum value of this equation to the maximum value of the other. The maximum value here is 9, okay? And he got 9, reached 9 in how many seconds? In 3 seconds. So the maximum height is 9 in 3 seconds. So now to find this one. So y equals, clear that out and type in the equation. That is negative 2x squared plus 8x plus 2. Okay, and so now let's graph it. All right, so let's go window. That's up to high. Let's set 30, so let's do 10. All right, that's a little bit better. All right, so we need to find this maximum height here. So second trace maximum. So we're going to do this side. Then we're going to do this side. All right, so the maximum height is at 2.1. All right, so which one has a greater maximum height? Of course, my goodness, is this one. So the maximum height, the one that has the maximum height, the height is 9. So for 25, uh, C is your answer, and it's 9. Okay. Number 26, a ball is thrown from the ground at a velocity of 64 feet per second. This is the formula here. Gives the ball this height after t seconds. How many seconds would it take for it to reach its maximum height? We're doing maximum height again. So let's type in the equation. Okay. So the equation is negative 16x squared plus 64x. That's it. Yep. All right. So we can go to the table and look, or we can go to the graph. Oops. And we go up. So let's go. Y needs to go up. Let's try 30. Okay. Let's try 40. Let's try 60. Change this. Oops. Why am I? All right. Finally. Good. So this is what we're trying to find here. So let's go second, trace, and maximum. So we're going to go on the left side over here, and then right side over here. And that's going to give us 64. So how many seconds did it take? It took 2 seconds to get to 64. So the answer here is 2. Okay? 2 seconds it took to get to 64. And you could have did an axis of symmetry there to get the answer. So for 26, because you could have did AOS to get that top part. So don't forget that you could do that. X is equal to negative B divided by 2A. You could have used that one. Number 27, what is the largest integer? Okay, so largest integer value such that X, and then we got the equation here, exceeds this equation. Okay, so we're gonna type both. We're gonna type both of them in. Okay, so when does one exceed over the other one? So y equals, clear that out. So let's type in the first equation. We got x squared minus 6x plus 40. Okay, and the second equation is 2 parentheses 1.5, and then we are going to caret key to the x power. So this is the exponential function. So let's look at the table. Okay, so that's second graph. And we're looking at the table to see when does this graph, it says x value x such that the value of the first equation we typed in exceeds or is greater than the second. So look, wait a minute. The largest integer. And you want to know exceeds the value. All right. Huh. Hmm. Okay, so this is when it starts getting more. This is still larger. This is still larger. So at 9. So when x is 9, this is when the second one gets larger than the first one. So when x is equal to 9, that's when the second one is greater. All right. What are the solutions to the equation? Okay, so the last one. So when we do this one, don't forget to write on your paper that number 27 is when x is equal to 9. Okay. All right, so the solution. So we are factoring this negative 2x squared plus the 10 is equal to 0. We're going to factor this right here, okay, to find the solutions. So first thing, greatest common factor is negative 2. So that's this here, okay? Um, is it t? Oh, this is t, so I can take out a t. Sorry. Do this again because I wrote it wrong. This is t. So take out a negative 2t. So this is just going to be t here. This is going to be plus 5. So now you're going to take each of these and set it equal to 0. Negative 2t is equal to 0. And t plus 5 is equal to 0. So you're going to divide both sides by a negative 2. And that's t is equal to 0. Then you're going to subtract both sides by 5. And that's 2 is equal to negative 5. So these are your two zeros, 0 and negative 5. So here, negative 5 and 0, 0, negative 5, that's right. And none of the other ones, yeah. So A here, A is your answer. Okay? All right, y'all, please go back and study. Please go back and study and do your absolute best, okay? Please do your absolute best on this test. Go back and study your notes. All right, y'all. Bye.